Our group is trying to study how oil behaves in the ocean. So in other words, when it interacts, if you have a surface oil slick, how do waves break it up? How does dispersant change the way that oil breaks up? How does oil behave when it's coming out of a wellhead that's run away on the bottom of the ocean? So we're trying to understand all the processes that affect how that oil breaks up into smaller particles, particularly if dispersants are used. It breaks up into very small particles. And then we're trying to understand how those small oil droplets interact with the base of the marine food web. So there are hydrocarbon degrading bacteria out there, and the size of the particle determines, to some extent, how quickly they're able to break that down. And we're also interested in how they interact with planktonic organisms, which are the base of the marine food web. When there's an oil spill, things get very chaotic, and they need to have the information that they need to decide whether dispersants, for example, or other methods should be used in order to try to clean it up. So we're just really trying to better understand the effects of dispersant, because as you know, in the Deepwater Horizon, that was the biggest application of dispersants in an oil spill that's ever occurred. And it was, and again, probably it seemed like a good idea at the time, but we're really trying to understand what the effects of that were on the marine environment, and then be able to then have better information to decide whether we should use it again in the future. Right, so we're a consortium of 7 universities. We're one of the smaller consortia. More than half of our group are engineers, so they're looking at the physics and the fluid dynamics of how oil and water interact. We've built big wave tanks. We've built other facilities where we can actually visualize how oil behaves in water. For example, if you we'll put a little circle of oil on the surface of water in a big wave tank, and then it'll have a wave break, and we have high-speed video, and we look at how it breaks up into smaller droplets, and we actually can get then empirical quantitative data on that. We also have people that will model that and try to make predictive models to understand that. And then we also carry out experiments with those sizes of oil droplets with hydrocarbon degrading bacteria and with planktonic organisms, so we can understand what impact it might have on the overall environment and how fast those bacteria would be able to degrade it, because those organisms are in turn going to be eaten by small fish and so on up into the types of food that human beings eat. So we really need to understand how those toxic compounds in oil are getting into the planktonic food web. So one of the things we discovered early on, which I think was probably one of the most interesting things, was when we were doing these wave tanks experiments, we realized that not only was the oil creating small droplets in the water, but it was also splashing small oil droplets up into the air. And so a lot of the oil is actually aerosolized as well, not only from the splash of the waves, but by when the bubbles, air is forced down into the water and then they break when they come back up. We've measured very, very small oil droplets in these aerosols, and they have the capability of being carried some distance and then being inhaled by people that work on cleaning up the oil spill. In fact, we've discovered that the oil droplets are so small, they're less than a micron in size, which is about the size of a bacterial cell. And so they're small enough to actually go through the masks that the workers use to try to protect themselves from some of these compounds. So we have a group in Johns Hopkins School of Public Health who historically have studied the effects of things like cigarette smoke. They have a human lung tissue cell culture, and so we're exposing these oily aerosols to that to try to get an idea of what the human health risks are. And we also are able to sort of quantify that. Now we have a big wave tank that also has a wind tunnel on top of it, so we can actually measure how much aerosol is being created. Because not only is it potentially harmful to the workers that are cleaning up the oil spill, but it could also be harmful to other air-breathing organisms, dolphins, sea turtles, birds that are near the surface of the ocean. So they could be breathing in these small particles as well. So we don't know whether there's normally enough of that oil to cause a problem, and we don't know how toxic it is to human lung tissue cells. So we hope we'll have a better answer for that. So that work is continuing. That work with the wave tank and with the wind tunnel on top is really just getting underway as well. We're also looking at the toxicity of the oil to small planktonic organisms in more complete way. So initially we did it on individual species of organisms. Now we're doing what we call mesocosm studies, where we just take a natural assemblage of all the different types of animals that are there, and then we do these exposures. And since they affect different groups of animals or of organisms at different oil concentrations, we found that the interactions are very complex and always not exactly what you'd expect. So some groups of organisms do better when there's oil there, and some do worse. And so, for example, we found that this actually has the capacity to help induce red tide blooms. because dinoflagellates turn out to be fairly resistant to oil, but all the things that eat them normally are actually very sensitive to the oil. So anyway, those are some of the examples of things that we want to do in the future.